Imagine asking your company chatbot, "What's our latest refund policy?" Or, "Explain this medical report," and it answers with context-aware, verified, accurate information straight from your organization's knowledge base. Welcome to the world of domain-specific chatbots, powered by RAG, Retrieval-Augmented Generation. Large language models are brilliant at conversation, but they have one big limitation. They don't know your data. They're trained on massive public datasets but lack access to private, domain-specific knowledge like enterprise documents, financial reports, legal contracts, medical case files. RAG combines the strengths of information retrieval and language generation. Here's how it works. Retrieve. When a user asks a question, the system searches a knowledge base, like PDFs, internal docs, or databases, for the most relevant chunks. Augment. These retrieved pieces are added to the prompt sent to the LLM. Generate. The model then produces a grounded, factual answer using both retrieved data and its general knowledge. RAG gives your chatbot access to private, dynamic knowledge without retraining the base LLM. This makes it scalable. Update your data, not your model. Secure, sensitive data stays within your environment. Accurate, reduces hallucinations. Customizable, tailored for healthcare, finance, law, education, etc. Let's look under the hood of a typical RAG pipeline. Step 1. Data ingestion. Load PDFs, documents, FAQs, or database records. Step 2. Chunking. Break data into meaningful text chunks for retrieval. Step 3. Embedding. Convert text chunks into numerical vectors using embedding models. Step 4. Storage. Store these vectors in a vector database like Pinecone, FAISS, or Chroma. Step 5. Retrieval. For every user query, retrieve the top relevant chunks. Step 6. Augmentation. Combine retrieved text with the query to form the prompt. Step 7. Generation. Send it to the LLM, OpenAI, Mistral, Llama, etc. to get the final answer. Let's take an example. A medical assistant bot for doctors and patients. Upload medical research papers, drug info, and patient FAQs. The system embeds and stores them in a vector database. When a doctor asks, "What's the recommended dosage for drug X in renal patients?" RAG retrieves relevant content from those docs, and the LLM forms a clear, safe, evidence-based reply. You don't have to build everything from scratch. Here are the popular RAG frameworks: LangChain, orchestration and pipeline control; LlamaIndex, data connectors and retrieval logic; Haystack, modular RAG framework for enterprises; vector stores, Pinecone, FAISS, Chroma; LLMs, GPT-4, Llama 3, Mistral, Claude; no-code tools, Floweyes, Dust, LangFlow. Here's how it looks in action. The user uploads internal HR policies, and the chatbot instantly becomes an HR assistant that knows your company rules better than any employee handbook. A few key things to get right. Use clean and chunked data. Garbage in, garbage out. Keep embeddings consistent across versions. Add citation or source links to boost trust. Cache recent queries to speed up performance. Avoid dumping raw PDFs directly. Don't let your chatbot hallucinate. Always grounded in retrieved data. RAG is not just a bridge, it's becoming the foundation for knowledge-aware autonomous agents. The future is retrieval-augmented reasoning, where agents not only retrieve facts but verify, analyze, and reason with them in real time. To sum up, RAG transforms chatbots from generic responders to domain experts. Whether it's healthcare, law, finance, or education, Retrieval-Augmented Generation helps you ground intelligence in your own data. Subscribe for more deep dives on agentic AI, RAG pipelines, and domain intelligence systems. And tell us in the comments, what domain chatbot would you build first?